site went live, they would want to keep adding new different UI modules. So we wanted to keep the UI module separate from the main presentation engine, essentially. We had something called a site configuration, which is also a separate repository. The idea of a site configuration is, if you see, it's basically site-specific configuration, right? Let's say I want to turn off Facebook's sharing for Germany, right? But I want to keep it enabled for other countries. So it's a site-specific configuration which I could turn on and off. And again, if you see, this is something which is independent of your application deployment, right? My application is live, but I could want to turn off my site configuration at any point in time. So we actually created a separate repository for this, which is basically just configuration files. And we had an independent Go deployment pipeline to promote your site configuration out to production whenever you actually want to do a change. Right. And finally, of course, we had the repository for the chef cookbooks. This is a repository which had all the chef-related code, all the infrastructure provisioning code was put into this repository. Right. So this is basically a very high-level overview of how the pipelines look like, and I'm going to go down into each component step by step. So you have, of course, your Git repositories triggering a build pipeline on a commit, right? Let's say it's build number 10. You pass the commit through a series of build pipelines, and once it's gone green, then you pass it over to deployment pipelines, which will actually take care of deploying to each of the environments. Let's say you have dev, QA, staging, and production, for example, right? And we actually had deployment pipelines per environment, and our deployments were using RPMs as artifact. I'll come back to why RPM is artifact, right? We had a single Go server, and the Go server doesn't do much. It just, so all that the Go server does is actually schedule the pipelines to run on the Go agent, right? So it's a Go agent which does the actual work of running the build pipelines, running the tests, doing the deployment and all that, right? So this is a very high-level view of, and the deployment is actually done through a chef server, right? So I'll come back to come to later on how exactly that works. Let's talk about the build pipeline first. So we basically have two stages, essentially, here, right? Stage 1 does the basic compile, unit test, and integration test. Nothing new here. This is your typical CI process. So, and stage 2 does the same thing, but it actually creates the artifact, right? So typical artifacts are your var or jar or whatever, right? In our case, we decided to create artifacts as RPM artifacts, right? And so the question could be, right, and before I go to why RPM artifacts, if you can see that, again, stage 2 runs only if stage 1 is success. If it doesn't even compile, no point in creating the RPM artifact. Okay? Sure. Sure. Whatever tool, whatever framework, yeah.
So, I mean, is there any big plugin kind of structure where you say that okay, install this plugin or?
With Go, you mentioned? Yeah. So Go actually doesn't try to support any kind of framework or tool out of the box. So all it does is it gives you a shell command to execute, right? And your shell basically will execute your build script. So if you are using Scala, we had SBT, symbol Scala build tool. Symbol build tool, and if you had used something else, you could, if you use Java player, you might have used Gradle as your build tool. But essentially what you see here is not Go doing the compile and unit test. Go is just invoking a build script, and build script actually does these things: compile, unit test, and integration test. So typically what you do is you will define a task in your build script, which will be invoked by Go, which will do these steps.
So like cache might be giving some result.
Yes.
Number of test pass and all those things. So
a test report.
Right,
so Go has this concept of artifacts. Every stage basically creates an artifact which is published to the Go server. So in this case, you will have a test artifact generated, which will be uploaded to the Go server, and anybody who wants to see the history can go to the pipeline, click on the artifact, and see the results that, okay, these main tests were run and whatever. So. Yeah. So all you tell Go is that you're going to create an artifact. The whole point of creating a build is that there's going to be some artifact, right? Your artifact for stage 1 is your test results. Your artifact for stage 2 is your RPM.
How that
Yeah.
result is created?
So your build script will create a test, right? It can be a JUnit XML file or it can be Cucumber HTML file. It can be anything, but it's created to a folder. All you do is tell Go, this is the folder that the artifacts will be created. And whatever be the artifact created there, Go will upload it. So Go doesn't really care what is the artifact, it's generic, but you tell the folder or the path where the artifact is created. So that is essentially the point. Yeah. Cool. Any other questions on this slide? Right. So why RPMs, right? Does it surprise you, people? Like why RPMs and not your typical jar or zip file or that's the typical other deployment package patterns that we follow, right? You create a zip file and just put it out there. Yeah. Right. Essentially, the point being that if you use RPMs, and we obviously had Red Hat servers as an environment, you can leverage the OS built-in package management tools, right? I mean, if I want to find out what version of the package is installed on any environment, all I need to do is go and fire yum command, do an yum info app, and I get it, right? If I want to install an application, all I need to do is yum install and the app name, right? So I'm leveraging all the OS built-in package management tools to deploy my application, and I have a standard way of deploying my application. For the ops guys, it's amazing, right? Because they don't need to care how exactly your app needs to be deployed. Whether it's a zip file or a jar file, where all they need to know is this is an RPM, and I just need to install the RPM and it works fine. Right? So as the RPMs, they ease deployment a lot, and you can treat your application just like any other deployment. And in your chef, you can basically say that, okay, install so-and-so RPM, which is not any different from installing Nginx or Apache or anything else, right? So you have standard way of deploying all anything essentially. No, Go implementation doesn't care about the artifact. It can be a zip file. So again, the way this works is that so Go will just upload the artifact. It can be a zip file or RPM, whatever. We choose to create the artifact as an RPM because we want to leverage the package management capabilities of the operating system as a best practice. Okay, now let's take the combination of build pipelines for each of the components, right? Let's say you have this sequence where you have web app, which is at build 10, UI modules are build number 5, service are build number 20, and sitecom is build number 2. Now you want to test the combination of this together, right? And that's what is supposed to go out into production. Before you put it to production, the first thing is it should at least pass your acceptance tests, your functional tests, right? So what you see here is Go has this concept of upstream pipeline and downstream pipeline. So what you see on the left is your upstream pipeline, which can actually push artifacts to your downstream, which is your acceptance test, right? And we have configured in such a way that acceptance test will take the combination of all of them, right? So for shorthand, I have mentioned the combination as web10, UI5, S20, SC2, which is just the build label which actually triggered the acceptance test. What it also indicates is that let's say it is this combination, right? And let's say somebody makes a check-in for services. So this will become build 21. Now we need to test the combination of all of this again with acceptance test, right? So this label combination will be web 10, UI5, services 21, and SC2, right? So what acceptance test will do is basically pick up the last green artifact from each of these pipelines, including the new pipeline which has just been triggered, right? If this becomes red, it won't trigger the pipeline because there's no point in triggering pipeline if it's red, right? But it's green, it triggers the pipeline, picks up the latest of all of them, and it will run your entire acceptance test suite against the combination. If that combination is green, then it's worthy enough to be promoted to your next environment, which is which the deployment pipelines will take care of promotion across environments. Cool. So this is a very important concept of Go, where you have this upstream and downstream pipelines. Yeah.
Like you might have on Go server, suppose your Jenkins server is in the different machine altogether. So when you define that task of Jenkins testing, so you also define all those server configuration, like how to reach it and how to go and run it.
Are you talking about a case where, in the case that you mentioned, where you might have to integrate with third-party applications or something like that? Because if it's my project, then I would have everything in Go, right? Why would I didn't get a point about Jenkins.
Yeah, I'm just asking is if suppose your tools are in the different machine server altogether, your Go is in one server, however your other tools are in a different server altogether.
Which other tools?
Like just take the example of maybe what I say Like there is some different server which might be running your unit test and the unit test,
So-
not in your, inside your Go server itself.
So that's what Go server doesn't do anything at all actually. All it does is schedules the pipelines around Go agents, and the Go agents does the actual work of running the
Yeah,
builds
that's-
and acceptance tests and
That's
everything.
what I was asking.
Right.
That you have to explicitly go and install the agents. in Go.
Yes, you need to have a collection of servers which will act as Go agents,
Okay.
and you have one server which will be a Go server.
Okay.
Right. You need to do that. So you need to have Go agents is nothing but your build agents essentially. Right. Yeah. So coming back to your question, I think it kind of partially answers your question, right? Let's say in case where you have third-party applications, right? And what we typically do is, so we'll have one more pipeline which will be fixing the version of that third-party application that you want to integrate with, and that can be then promoted across pipelines. It's a bit more involved. I can talk offline about it. Right? Yeah. This bit here, blue. This entire bit I'm calling the build pipeline. Rest is the deployment pipeline. So my build pipeline includes the builds for each of the components, right? Which will run the unit test, integration test, artifact generation, everything. And it also includes an additional acceptance test which tests everything together. Because without the acceptance test going green, my changes are not worth promoting to any environment. Right. So the left-hand side is fully, the blue is build pipelines essentially. Now let's talk about something called Go's fetch artifact task, right? So it's interesting, and this is what actually enables the promotion of artifacts. So you have an upstream pipeline, build web 10, and a downstream which is not yet triggered, right? When the upstream pipeline completes, it actually goes green. What it does is publishes the artifact to the Go server, let's say web 10 RPM, some RPM, right? And then the upstream will trigger the downstream to execute. So this has gone green, now it triggers the downstream, right? When the downstream is triggered, it will do a fetch artifact. It's a fetch artifact, it's a task built into Go, right? And when it does a fetch artifact, it will automatically pick up the RPM or the artifact of the version which was generated by the corresponding upstream pipeline which triggered it, right? So that's a feature in Go, which is very useful for, and this is the key feature which actually enables you to promote artifact across a series of pipelines. That every downstream pipeline, when it doesn't fetch artifact, it will fetch the corresponding artifact from the upstream which triggered that downstream, right? So that's why you can always match it. And again, this is all based on green builds. It will never pick up an artifact from the upstream which is red. That won't happen. So always green builds throughout which gets promoted. Any questions on this topic? The promotion, fetch artifact, yeah.
We have upstream pipeline has published 2 artifacts, right?
Right.
And let's say there is a half an hour just latency between the 2 artifacts which are published.
Okay.
So the downstream is still busy doing that.
Right. So downstream so you can, in your downstream, you can specify after the completion of what stage in the upstream should you actually trigger it, right? So in your case where, let's say I'm publishing multiple artifacts, I wouldn't configure my downstream to trigger till the last stage has completed, which means my last artifact has been published. So that's a feature in Go where if this upstream had 3 stages, right, I will not trigger the downstream to run on the completion of the first stage, but that doesn't make sense because my artifact is generated in the last stage. So I would make it trigger only on the completion of the last stage. So I can basically ensure that whenever downstream runs, the artifacts are already in place and it can be downloaded. Dependency between different artifacts. So that so all this guy does is just uploads the artifacts to the Go server, and then I can decide in my downstream which artifacts I care about, which I should download and all that. So I'll download artifact 1 first and then artifact second. That's how basically it's done.
Like if you are someone is using Nexus and all that, they are pushing their artifacts in the
Nexus, yeah.
So that way also you can work.
That way also it can work. It's not Go doesn't have any built-in support for Nexus and all that, but you can basically write your build scripts to kind of do that.
Multiple developers checking the code almost at the same time. Let's say
Right.
peak of 15,
Yeah.
I check the code at 10 and 10 to another developer at 10 for maintaining different variations.
Right. So so Go has this polling interval, which is just like any other CI tool. Like I think you can configure the polling interval as well. As long as you check in within the polling interval, it will be treated as one build. So sometimes you have one build triggered and that has, let's say, 2 or 3 commits. Happens sometimes. But usually if it's outside the polling interval, it will be a separate build pipeline, separate build run, and then you can track each commit to that separate build run.
Are you saying the build is triggered by Go server?
The build is triggered, so Go server actually monitors your GitHub or Git server, and for every check-in, which is outside the polling interval, it will actually trigger a build run, essentially.
So let's say if your build is running on a cruise control or TFS,
Yeah,
and GitHub is a source code,
yeah.
saying that
When you check into GitHub, it will trigger a build, basically.
now your Go would keep monitoring and then
Yeah.
next 10 minutes is a polling interval, you'll check if there's something new.
Right.
If there is something new,
Right.
you go and tell the cruise control, okay, hey, so you take the time.
So Go will actually schedule the pipeline. So Go server will keep monitoring the source control, and if it finds a check-in, it will schedule the pipeline to execute, and the pipeline will actually execute on your Go agent. So that's the flow.
Is there any integration with the ID?
With IDs,
I mean, as a developer, if I can just commit it and maybe in my IntelliJ only
no, I don't think we have. What we have is there is something called CC tray feed as XML feed of the status of the pipelines. And you can have something called CC menu, which is system tray, which comes up in your system tray, right? But no ID support as that. I'm not aware of. I'm not aware of that. Yeah. Okay. So moving on, this is an example of RTY promotion across deployment pipelines. So you had your acceptance test here, which is the build pipeline, right? And what you see here is that the artifact which is promoted to dev, this happens on every. This is an automatic promotion. So for every green acceptance test, we automatically deploy it to the dev environment, right? And for the QA,